Hi class. Today we're going to continue talking about, in chapter 10, about two samples. And in 10.4 we'll look at two samples where they're matched pairs. So matched pairs means there's some type of dependence between the two. Maybe we're comparing your left hand to your right hand, or your brother to your sister. There's some type of matching up. Let's first start by looking at the requirements. So in order to be a matched pair, the first thing that we're going to need is two dependent samples. And that's what we call a matched pair. Second, the samples, of course, need to be random. And third, both samples need to be of the size of 30 or more. So both samples are 30 or more. Or they need to be both from a normal distribution. All right. Let's look at our test statistic. When we have our matched pairs, we're going to be looking at the t-test. It's slightly different. First, we need to find the difference between your left hand and your right hand, the difference between the brother and the sister. So we would find all the differences and find the mean of those. We'll need to review chapter 3, and we'll compare that to what we think the population difference is. And all of that will be taken in relationship to the standard deviation of those differences divided by the square root of n. Remember, when we use the t-test, we have degrees of freedom. Again, but not all semester, but again, degrees of freedom will be n minus 1. And we'll also have confidence intervals to look at. We might want to make an estimate. And the formula for our confidence interval is going to be d bar plus or minus the margin of error, where the margin of error is the t-score times the standard deviation of the samples divided by the square root of n. Let's just make sure now you remember how to use your calculator. So we'll look at a sample where we have a d bar value, mu of d, s standard deviation for the differences, and a sample size. Let's say the differences between brother and sister is 40. And the population mean is 0. That's what we expect. The standard deviation is 10. And the sample size is 25. So to find the test statistic, we'd have our d bar minus our population mean of the differences divided by the standard deviation over the square root of the sample size. And throwing that into a calculator, we get a rather large test statistic of 20, which probably means we would, if we have a large test statistic, we probably have a small p-value, and we would expect to fail to reject H naught when we look at our hypothesis test. All right, I'll look for your questions on the discussion board. Until next time.